Hello student. In superposition of waves, the formation of stationary waves in terms of antinodes and nodes are formed in a stationary wave. But when the pipe closed at one end and pipe open at both end correction factor that is included in that expression. What is meant by end correction? End correction Antinode is, in practically, antinode is not exactly formed at its open end, but above its open end. Therefore, the corrected length can be calculated by capital L is equal to small l. L means vibrating length of air column plus end correction factor. E is denoted by end correction factor. L is equal to capital L is equal to small l plus E. Where what is meant by end correction? Distance between open end of pipe and position of antinode. Antinode is formed at that position where the distance between open end of pipe and position of antinode is called end correction. End correction factor is calculated by E is equal to 0.3 into inner diameter of the pipe. Inner diameter of pipe means 0.3 into inner diameter. Inner diameter of pipe. That inner diameter can be calculated by using vernier caliper. Therefore, the end correction factor can be calculated by E is equal to 0.3 into diameter D. That corrected length can be calculated, and for pipe closed at one end, the frequency of the tuning fork can be calculated by using formula fundamental frequency N is equal to V upon 4L. V upon 4L means where the velocity of the organ pipe or a pipe is same, means V is equal to 4NL. V is equal to 4NL. But considering the two pipes having length L1 and L2, therefore V is equal to 4N1L1 is equal to 4N2L2. 4 get cancelled. Therefore, the terms N1L1 is equal to N2L2. But pipe closed at one end, the corrected length is calculated by L plus end correction. Because of one end is closed, therefore no end correction factor in that side. Only end correction factor at the open end. Therefore L plus E. Substitute that equation. N1 in bracket L plus E is equal to N2 in bracket L plus E. Vibrating length plus E. Where L1 length and here L2 length will be considered. N1 L1 plus N1E is equal to N2 L2 plus N2 E. Hence, N1 L1 minus N2 L2, N1 L1 minus N2 L2 is equal to N2E, N2 minus N1 multiplied by end correction factor. Therefore, end correction factor when pipe closed at one end should be calculated by N1 L1 minus N2 L2 upon N2 minus N1. That end correction factor's value for a pipe closed at one end should be calculated by using that formula. E is equal to N1 L1 minus N2 L2 upon N2 minus N1. Similarly, we can calculate the end correction factor for pipe open at both ends. But when pipe open at both ends, the frequency, fundamental frequency N is equal to V upon twice L, where V is equal to twice N1 L2, L1 is equal to twice N2 L2, to get cancelled. Therefore, the term N1 L1 is equal to N2 L2. But end correction factor should be added in the vibrating length in two times, where because of the pipe is open at both ends. Therefore, L1 is equal to N1 in bracket L1 plus twice E is equal to N2 in bracket L2 plus twice E. Multiplying that term, N1 L1 plus twice E into N1 is equal to N2 L2 plus twice E N2. N1 L1 end correction factor E is equal to N1 L1 minus N2 L2. N1 L1 minus N2 L2 is equal to 2E in bracket N2 minus N1. 2E in bracket N2 minus N1. Therefore, that terms end correction factor E is equal to N1 L1 minus N2 L2 upon 2 in bracket N2 minus N1. That formula can be used for calculation of end correction of the pipe open at both ends.